The most essential topics in chemistry, it's called electrochemistry or electricity and chemistry. You can call it electrolysis. Nonetheless, it's all about you taking these ionic compounds like salt and splitting them. Meaning, when we took the lesson of ionic bonding, we said that you have positive ions, negative ions combine to form an ionic compound. This lesson is like the complete opposite. This is when you divorce these positive and negative ions. But to do so, you need to supply electricity because the bonds is strong. You have strong electrostatic attraction between the positive and negative. And while being solid, while ionic compounds are in solid form, it's nearly impossible to split them apart. So guess what we have to do first? We first have to dissolve or melt those ionic compounds. Again, as they are, the way they are here, they are in the solid form. Ions don't move, and when ions don't move, they don't conduct electricity. So to do so, we have somehow to either take those ionic compounds, dissolve in water. You dissolve them in water, they are free to move. Alternatively, you're gonna take these salts and melt it. Okay, so take source of heat and you melt it. When they are dissolved or molten, that is when they conduct electricity. So I really want those ionic compounds to be in this flowing form. And again, that's either when they're molten or when they are dissolved in water. So electrolysis is the action when you supply electricity, usually comes from a battery, and your task is what? Your task is simple. Supply the electricity so that you can separate the positive and negative ions from those ionic compounds. So before we get into the details of electrolysis, I would like you to try this. I want you to figure out how many of these things in front of you conduct electricity and how many of them do not conduct electricity. So in the chat, Zoom chat, tell me which one conducts, put C, and put D for those that do not conduct electricity. So can we try this? So again, I'm going to show you the item here, and you guys put C or D. Conduct C, doesn't conduct D. Graphite conducts. Graphite has free mobile electrons. Diamond does not. Doesn't have free mobile electrons. Acids, what do you think? Acids have free ions. Acids are simply ionic compounds dissolved in water. So it does. But how about water? Does water conduct electricity? It does. That's why wet surfaces are quite risky. If there is any electricity, if there is any short in electricity, they could harm someone. If it's a molten ionic compound, again, how do I know if it's an ionic compound? You would simply find it's a metal, non-metal. So that's molten, it does. We just said it, right? But what if it's aqueous? Aqueous ionic compound does not conduct or doesn't conduct. What do you think? Still, right? Now I have these three forms of sodium chloride. Solid, aqueous, liquid. What does liquid mean? Liquid means it's molten, right? So for that reason, the only forms that conduct is aqueous and the liquid form. But when it's solid, as we've said several times, that doesn't conduct electricity. Good. So now we have, hopefully, some clear idea on what conducts and what doesn't conduct electricity. Let me try this with you. Ionic compounds, they are made up of, so what is an ionic compound made up of? You tell me, please?
Can you hear me?
Yeah, I do.
Ions.
That's right. Positive and negative ions. Very good. They are what state of matter ionic compounds are at room temperature. So all ionic compounds at room temperature, they must be
Solid.
That's right. They have melting and boiling point. So what's the melting boiling point is like for any ionic compound? That's one of their physical properties. So for an ionic compounds, you tell me, what do you think is the melting boiling point is like there?
They're very high.
They're very high. And they are in water. Majority of ionic compounds are actually soluble. Moreover, they cannot conduct electricity when, in which state they do not conduct electricity?
Solid.
They do not conduct electricity when they are in the solid state. That's right. All right. Moreover, they can conduct electricity in one of two forms.
Solid and aqueous.
So when they are either molten or when they are in their aqueous form. Okay? Any question?
Sir, in the question 6, it says dissolved in the salts.
When they are dissolved in water, I should say. Yes, water. You're right. Okay. Good. Now let's see the setup you will require to do electrolysis. Again, what does it mean when I say electrolysis? Electrolysis means splitting an ionic compound. So let me show you how do you actually do this electrolysis thing. To start with, you will need a supply of electricity. So for that, I need a battery. So usually, battery, we have positive, negative sides. Usually the positive is the long part of the battery here. That's positive. And negative is the short form, okay? So me, I'm drawing a battery, do it like this. Positive, negative, okay? You know this from physics. Now, this cannot be simply put into the ionic compounds. For that, I will require what we call electrodes. So those electrodes are going to be helpful because those are the ones that will pass the electricity into the ionic compound. Now, the best material to use for electrodes is graphite, simply because graphite conducts electricity. That's number one. Second, because it doesn't react. Okay, so again, the best choice for electrodes is either you pick graphite or platinum. Why am I picking those two? Graphite, again, it's a non-metal. It's not gonna react with the ionic compound, quite inert. Inert means unreactive. And platinum is the same thing. So they're both very good conductors and they are unreactive. School, we use graphite because it's way cheaper than platinum. So that's here, that's here. So again, by default, when I connect this to the battery with the wires, this one here is going to be my negative electrode, and this one here is going to be my positive electrodes. So one more time, these are my electrodes, and electrodes is what I'm going to use here to pass the electricity into my ionic compound. Okay? Now, these electrodes, because they're no longer different, they used to be different, right? They used to be separate, just pieces of graphite, but now one of them is positive, one of them is negative. I have now to assign names for these electrodes. Usually, isn't that the negative one? This is the negative one, right? The negative electrode is gonna attract the positive ions. I repeat, the ions are floating around, right? Didn't we say we have positive and negative ions? They're attracted like this. They've been dissolved into water like this. These will now have the ability to travel. They've been dissolved, they travel, and each is supposed to travel to the electrode of the opposite charge. In other words, do you see that negative chloride ion? This electrode, this negative chloride ion is going to be attracted to the positive electrode. You know that part, that negatives attract to positive. So this is going to come here, okay? And the positive, on the other hand, because it's positive, is going to get attracted to the negative electrode. Okay? So in the ionic compound, once it's been dissolved, it has freedom to swim, to float, to travel to the opposite charge, where the negative goes to the positive electrode and the positive goes to the negative electrode. Now, remember, a positive ion has, we call it usually cation, right? You know that part. And the negative ion, so you have the negative ion, we call this a negative ion. Remember, that T in cation tells me it's a positive, and the A negative ion is actually written in the name. Now, the way we're going to name these electrodes is based on that. So, didn't we say that the positive is attracted here to the negative? Then this is going to be called a cathode. Again, why did we call it a cathode? Because it attracts the cations. And why am I calling this one anode? It's called an anode because it attracts the negative ion, it attracts the anions, right? So cathode, anode, okay? Cathode is the one that is attracting the anions. Sorry, anode is the one attracting the anions, and cathode is the one attracting the cations. One way to remember it is like this: positive is anode, negative is cathode. Okay? So I'll draw this one more time. Battery, positive, negative, some wires like this. You have an electrode made of graphite. You have another electrode made of graphite. You dip these into a solution of an ionic compound. You'll find that the negative anions get to the positive. So this is going to be called an anode. And you'll find that the positive cations are attracted to the cathode. Okay? And one way to remember this, we say positive is anode. Negative is cathode. Positive, negative. Okay? What about this like dissolved or molten ionic compound? Usually that's what we call an electrolyte. So an electrolyte is simply an ionic compound that's either molten and dissolved, and that's why I'm trying to split. That's why I'm trying to separate. Okay? You have a question? Tell me.
Mister, we use graphite and platinum for electrodes because it's unreactive and what?
Unreactive and good conductor.
Oh, okay, thank you, miss.
All right? Good. Question? Any question?
Mr. Question.
Tell me, what's your question?
Mr. So, like, cathode is the negative, what was it called? Rod, okay?
Yeah.
And the anode is the positive, and both attract the opposite,
Charge.
Yeah.
Yeah.
That's it, right?
Yes.
Okay, thank you.
What's your question? Okay.
No problem.
All right. Good. Right. So, just quick conclusion maybe. Cathode attracts cations, it's negative. Anode attracts anions and is positive. Right, let's try something. Let's try this together. Let's try to label this process, okay? Electrolysis. I will start with the labels of the ions. So take a look and tell me which one is cation and which one is anion. Write me the letter in the chat. Tell me which one of those letters is for cation. First, cation. Which letter is cation? Take a look. So on mine here, D is cation, right? And C, the negative, is the anion, right? So again, I got anions, cations, okay? Now let's try to label the electrodes, okay? So electrode positive, what was the positive one called? The positive is anode, so that one here is anode, okay? Attracting the anions. And that one here is the cathode. How about the solution? The solution itself, we said it's called an electrolyte. Now, there's a chemical reaction happening there. There is negative ions going to the positive and not positive going to the negative. So we do have loss and gain of electrons. And when you have loss and gain of electrons, that's always redox. For that reason, we have to figure out where does oxidation happen and where does reduction take place. So let's take a look here. Oil rig, remember? So gain of electrons. When the positive ion gains an electron, where is this electron coming from? It's coming from the battery. The battery gives me that electron. So when the positive travels and gains an electron, I'm gonna call that reduction, right? So remember, oil rig, okay? So reduction is gain. And the loss, which is oil part, the loss is oxidation, right? So you don't need that redox part for today's lesson. It's just like to remember that this involves loss and gain of electrons. And once again, there is a shortcut to remember what's happening. You can learn this quickly like this. You say red cat. Reduction is always at the cathode. Okay? Why is it reduction is at the cathode? Because the positive will gain an electron. Okay? What about the negative? An ox is an ox. So I say the negative one is gonna lose an electron and becomes chlorine. That's loss, right? When the electron is on the right side, that is loss and that is gain. Okay, so again, reduction cathode, oxidation always at the anode. So if someone tells you, where does reduction takes place? It's always at the cathode, at the negative electrode. Okay, going back to my question here, it was asking me, where does oxidation, where does reduction take place? Simply, I'll say here, oxidation and ox, right? So anode. And reduction, red cat, cathode, always here, okay? And if you could like to write the equation here, so that is going to be negative ion. I'm just going to call it N negative. It's going to lose an electron. And here I'm going to call it P positive ion. It's going to gain and becomes like this. This P and N just symbols. They're not actual elements, okay? And the equation is always going to be in this format. Okay? Makes sense. Good. Now, let me show you some equations. And what we're going to do, we're just going to try to apply this. I'll put this here. And I'll put this here. And you guys help me with each one of those equations I'm going to show you. Here's my first one. Cl negative. First of all, we're going to try to figure out where will this appear. Will this appear at the cathode? Will this appear at the anode? Cathode, anode.
Answer?
Yeah, please.
Sorry, it's oxidation, so it's going to be at the anode.
So that is anode and it's oxidation. Do you know how to complete this equation?
Yes.
Tell me.
So Cn minus goes to E minus plus Cl2.
That's right. Remember, guys, that the Cl2 is always diatomic. Chlorine doesn't exist. When it's a chlorine, when it's an element, not an ion. When it's an ion, it can exist as one Cl minus. But when it's an element, it would always be as a Cl2. What other elements always exist as diatoms? Remember, we had one mnemonic for this. It was called Brin-Kil-Hoff, okay? So all of these, when they form at the anode, why did I say anode? Because they're all nonmetals, they're all negative, and they will always be as diatoms, okay? So let's try another one. You guys tell me the same thing. Where will it happen and what type of process is it gonna be? Here's my other one. Na plus, cathode, anode, oxidation or reduction. Can we try this one? So, Tamim?
This is gonna be reduction.
So that is
What is the
reduction.
cathode?
Right, there's one. So reduction, red cat, always at the cathode. Good. I have another one here. You guys tell me, where is this going to happen? Be careful, that's a bromide. So this should remind you of Bryn in Brinkelhof, okay? So where would you expect this to take place?
Is it oxidation and then it will take place at the anode?
So oxidation and at the anode, right? So this is going to be negative, and here I'm going to have to write Br2. I'm going to put 2. Okay. So someone's asking me, what does that mean? These are all elements that exist as diatoms. So O, how do you write oxygen? You will always write it as O2. How do you write nitrogen? You always write it as N2. Okay? Now, how about this guy here? I have H plus. By the way, where would you expect H plus is going to be? Anyone? Hams?
Reduction.
So
Which
that is
positive?
gonna be, yeah, it's gonna gain an electron because it's positive, and it's going to be H2. Therefore, I have to balance, right? Put 2 here, 2 positives, then there must be 2 negatives to cancel out. And as she said, because this is at the cathode, why is it at the cathode? Because it's a cation, then it must be reduction. Okay? Yep, so this is Br2, I just have to balance. Anyone? I still have few more to go. I got copper. So let's do copper here. So Cu2 plus. So how do I get to complete this equation, and where is it going to take place? Let me try. Mr. Aiden, can you try?
This takes place at the anode, and this is oxidation.
So he thought it's an anode, and he thought it was oxidation. Now, isn't this positive?
Oh
Aiden?
wait, I see. So it's cathode and reduction.
So cathode and reduction. 2 plus must gain 2e minus, right? So that's the enough number of electrons. And the product is going to be copper. I got few more here, just 2 more. I got aluminium. So where is this gonna happen? And how many electrons do I require to complete this equation? Hamza?
Yes, sir.
Can you complete that equation?
It's going to be reduction cathode.
So reduction and cathode. So 3e minus and Al. Right? One more. Let's try Judy. Last one.
It's gonna be oxidation and anode.
So oxidation and anode. Now, just let's take a look at this one here. Again, on the right side, I have to write oxygen. O2. Because as we said, it doesn't exist as an O. Now I balance it, right? So I need to put 2 here. How many negative charges do I have at the moment? Right now I have 2 times 2, 4 negative charges. So what am I supposed to put next to it here? 4E minus. If you're confused about these equations, there's a way you can learn it and learn it for all the time. So let's write general equation at the cathode and general equation at the anode, okay? So, cathode. What is the equation always going to look like? It's going to be a metal. Has to be a metal. Why? Because it's the positive. It's going to gain number of electrons and it's become metal in its atomic form. Okay? What if this was like 2 plus? Then you put 2 here. What if it was like 3 plus? Then you put 3 here. It's not rocket science. Just you match this with the number of electrons. Alternatively, you may get one gas. There's only one gas that forms at the cathode. And guess what the gas is? The only gas that forms at the cathode is this. Okay? And again, you need to provide electrons and you need to put H2 on the right. Balance it, right? Because there's 2 H's here, then I put 2 here. I'm missing one last thing just to perfect this equation. I need to put 2 here. Good. So that is the only thing you can have at the cathode. What about the anode? For the anode, it's always going to be a non-metal. N here for non-metal. And it's always going to be negative. And it's always going to have the electrons on the right-hand side. And here it will always be, because it's a non-metal, because it's a gas, it's going to have to put 2. Okay? Then you balance it. All right? So try this. So you could perfect write in these equations, the cathode and the anode. So next time, you sub that N with chlorine, bromine, iodine, and you sub that M with sodium, aluminium, calcium, any metal. Okay? Someone's asking me, where do you get the charge from? This comes from the periodic table. You get the charge of the element from the periodic table. Why did you put an arrow instead of negative? Where did I put an arrow instead of negative? What are you talking about?
Well, Mister, I think like in the previous example, there was like in the anode or oxidation, it was like so it's gonna be N minus. So one of those. Oh, okay. So it's arrow.
So
right?
here, cathode is gonna be always, we said red cat. So that is going to be reduction all the time.
It's gonna be.
And here on the other side, that's gonna be an ox. It's always gonna be oxidation. Okay?
So okay, sir, we just like do the opposite.
That's right.
So here, okay, thank you.
So could you guys learn this? Because this is gonna be the basics of this entire lesson. Good. I want now to show you how does this thing work in real time. Like how do you do electrolysis in real time? And we always model this thing with lead bromide. You may tell me like, why is it lead bromide the best choice? Because you see it. Lead bromide shows you the process. It shows you colors. Always colors is the only way we can see chemical equations. So look what I'm going to do. First step, I will take some powdered ionic compound. Do you see where it is? It's right here. maybe pixelated like this, but here I have some solid lead bromide. Guess what am I supposed to do first before I even think about electrolysis here? Step one must be melting it. So I'm gonna melt that lead bromide. I'm gonna turn it into the molten liquid form to start the equation. Let me show you why. Let me show you why is this necessary. This is gonna have to be necessary because as it is, if you try to connect the voltmeter, the way we see if there is any electricity, guess what the reading is gonna be like for the voltmeter when it's solid? 0. No electricity is passing. So when it's a solid ionic compound, no charge, no flow of charge. Okay? For that reason, I will turn on the Bunsen burner and I'll start melting it. When it's molten, these ions are now moving. They are free to move, right? And when they are free to move, guess what will the voltmeter reading is going to be like? This time, when it's molten, the reading is going to be different. See, it's getting molten here. And see, it's a change of color. And that brown color tells me something. That brown color tells me that there's bromine. Bromine is brown. See? So once again, do you see that voltmeter reading? It's showing me that electricity is passing. So again, quick conclusion before you start electrolysis of let me make it bigger, of a solid ionic compound, you must melt it / dissolve. Most of today's lesson is gonna be about you melting. Next time we're gonna be dissolving, okay? So let's see what are the observations we're gonna have here. First observation is that you will notice some brown gas forming at the anode. So you see something brown, really toxic. You do this, you inhale it, you won't survive. Very, very toxic. All halogens, chlorine, bromine, iodine, fluorine, all of them are toxic. So that's why I would never do something like this in closed room. You will kill yourself and you kill everyone around. You don't want that. So that is bromine forming at the anode. Okay? What about the cathode? What am I expected to get here? Really, you start to see that your cathode is plated. You start to see that the cathode graphite starts to be covered with a metal. What's the metal? The metal was lead. So you find that cathode is covered with lead. So once again, at the positive, what was the equation we always write at the positive? It was negative electron N2, okay? So in my case, it's bromide, so I'm just gonna write it Br minus. This one is the format, okay? That's the format of all of my equations. So mine here is Br minus, 2Br minus, becomes what? Becomes Br2 and 2 electrons. Okay? What about the cathode? I have lead. Lead's charge is 2+. It will be given to you because it's not something you get from the periodic. So Pb2+, again, this 2+ is going to be given to you in the question. 2E minus, and it becomes lead. If you're confused, this is just like the way I showed you here, except that instead of 3, it's actually now 2. 2 here and 2 here. And this was Br minus Br2. Always, always, the equations are the same. Okay? Now, I want you to try this with me. I want you to make a quick comparison between what happens at the cathode and what happens at the anode, okay? Cathode is going to be letter C, anode is going to be letter A. Can we try this? Can somebody like do it all, him, herself? Like do this entire thing? Who's brave enough to try this whole thing? I want someone like super confident. We could do this entire thing. Just classify the items into cathode or anode. Leah, can you try?
Yes.
Okay.
The anode is the positive one.
Okay.
The anions are always going to the cathode. I mean, yeah. No, the anode, sorry, the anode.
Anions, anode, right? Anions, the sound tells you where they're gonna go, okay? Go. Oxidation.
Oxidation is at the anode.
And ox, yeah.
Is that lead?
Yeah, lead, metal.
Oh, that's the cathode.
Metals, cations, cathode, right? Aluminium.
Aluminum is also the cathode.
Right.
Bromine is the anode. Reduction is the cathode.
Red cat.
Cations are at the cathode as well.
Yup.
And hydrogen is positively charged, so it's at the cathode.
That's amazing. Really good. Excellent. Good. Now, do you have any question? Please tell me if you got any question. Again, how did she find out? Whenever you have a non-metal, that's an anion, definitely anode. Okay? Someone's telling me, what about hydrogen? Hydrogen, we said it's the only gas. Why hydrogen goes to the cathode? Because it's H+. Hydrogen, although it's a gas, but the ion of hydrogen has one electron. So it's going to be H+.
So I have a question.
Yeah.
For the bromide equation, we always memorize for the positive one, we use the N- equation.
Yeah.
And for the negative electrode, we use the other equation.
Or the hydrogen.
For like every single thing, single one?
Everything.
Okay.
Good. All right. Let's try this. Let's try a molten. It's like a summary of what we've done so far. A molten ionic compound conducts electricity because its ions are to move. So when it's molten, what is the property that allows the ions, or how you describe this in real time? Lujain? They are
free to move.
Free to move. Good. Free to move. Next one, it says when a current is passed through A, it splits it up into its element. So when a current is passed through maybe molten, then the ions are free to move. This process, what do I call this process we're learning about today? Yusuf?
Yes.
What's the name of that process?
Electrolysis.
Electrolysis, that's right. The electrolysis of molten lead bromide produces... Ahmed, Hussam?
Lead.
That's right. And?
Bromine.
Bromine, good one. So bromine. At the electrode Br minus. So where will the Br minus, it's a minus, it's a negative ion. So where would you expect it to form? Ahmed Mamdouh.
Anode.
So that's gonna be anode, good one. Which is the positive, yeah.
Normal ions.
So Br minus because it's loose. Why is it loose? Because it's anode.
Because anode.
And oil rig, right? Oxidation is loss of electrons. Br minus turns to bromine. What? You remember what we saw there while we were doing this electrolysis? We saw some brown gas. That's gonna be bromine gas or bromine molecules. Now, where would you expect the positive ion to form? So the positive ion, where is this going to form in my case? It's gonna be the anode. Sorry, the negative, right? This is positive, isn't it? Positive cathode.
So cathode.
Positive cation cathode. Electrons and so are, in my case here, at the negative ions gain electrons. When you gain, that's a rig, oil rig. So it's gonna be reduction, okay? Reduced. Finally, lead turns to lead atoms to form pure molten lead. So the lead cations turn into lead atoms, forming molten lead. Good? Okay, let's try one of these questions. I'm gonna show you a question here. You guys tell me what is the correct definition. So let's try the first one. Choose the correct answer. Which of the following is the correct definition of oxidation? It's called oil rig for a reason, right? So I must be picking option B, right? Another one. Which is the half equation? Which one of these half equations you have here? Which one of them is reduction?
Muted.
Oops, sorry. So which one of these half equations shows reduction? Can we find reduction for these? Again, reduction is always going to be gain of electrons, right? So you need to pick one where is expected to take place at the reduction red cat at the cathode. So I need something at the cathode, in other words. So it can't be A because this is negative. This can't be A. It can't be C. It can't be D. On the other hand, it must be B. Once again, reduction at the cathode. And how will a reduction equation look like? It's always going to be like M plus electron M, or the hydrogen equation you have in front of you. Okay? All right, now I want to show you another example of electrolysis. This time, it's gonna be for salt, like table salt, sodium chloride. So again, what are the ions I have here? Simply is gonna be Na plus Cl minus. And how's this equation? What's gonna happen here? You would, first of all, you have to melt it. Step one, you melt it. You're gonna have to have a battery, positive, negative, this, wires, electrodes, this. Remember, the electrode's gonna have to be made of graphite. And here is my molten sodium chloride. Let's assume it's right here. So what is expected to happen here? The Na plus, first of all, is gonna visit the cathode. So that's my cathode. And my Cl minus is gonna visit the anode, right? It's gonna go and visit the anode. Cations visit cathode, anions visit the anode. What is going to happen here? For the sodium plus, for the Na plus, let's write it again, it's going to gain 1 electron because its charge is 1 plus, and it's going to become Na. That's my first. The Cl minus, it's going to lose electron and form chlorine. Cl2 molecule. How do you balance this? Just like every time you put 2 and you put 2. I think I'd better write it in another color. So 2Cl minus becomes Cl2 and 2E minus. Always the same format at the anode. N minus, 2N minus becomes N2 and 2E minus. In terms of observation, what are you expected to see there at the cathode? Always, at the cathode, you will have some metal forming there. Your choice of colors is going to be one of two things. I repeat, when they ask you for observation at the cathode, you will always say metal forms, you may say metal deposit, but you somehow need to tell them some other observation, state the color of the metal. And guess what 99% of metals colors are? Most metals are silver. Okay? So you tell them silver metal forms at the cathode. We have two exceptions. Copper, you say brown. If it was copper, you say brown. And the other one, which is less likely, gold. I'm not gonna do electrolysis of gold. So again, everywhere you say silvery metal forms at the cathode. If it was copper, you say brown or orange metal. How about the anode? You will say some halogen forms, okay? And depending on the color of the halogens. What are the colors of halogens that you should be aware of here? For chlorine, it's going to be pale green. For bromine, it's going to be brown. And for iodine, you just have to say black/purple. Why black? Because iodine is black. Iodine is a black solid. When it's in the gas form, you remember iodine sublimes. Iodine turns straight solid to gas. So you would say either black solid or purple fumes. if they ask you about the electrolyte itself, if they ask you about what has happened here, like what's going to happen to this molten ionic compound, simply you're going to tell them what? You're going to tell them it is used up. Got used up. What does that mean? Finished. Why did it finish? Because the positive ions turn to metal and the negative ions turn to gas. So we used it up. All right? So again, when they ask you observations, which is very common, observation meaning you're going to tell them what do you see, okay? So always cathode, you'll simply state either bubbles. When is the only time you say bubbles at the cathode? That's where you have hydrogen. Or you say metal forms, and here you're going to say one of two things. You either say silver metal or you say brown. You'll say silver all the time except when it's copper. For copper, the color of copper metal is brown. How about the anode? What are you meant to say about the anode? So anode this time, you only say bubbles, and you have 1, 2, 3. You can say chlorine. What color is chlorine gas? Pale green. What color is bromine? Is brown. And for iodine, you can say it's black. Can't write in black here. Okay? Black solid forms. Question, she says, in molten electrolytes, it is always halogen? Yes. It's always halogen when it's a molten, and it's always at the anode. So can you note those observations? Brown and pale green.
They're all of those separate than the already one that has been printed?
What do you mean?
Like there's already one that has been printed on the sheet, so...
If you have it printed, then like use the printed one. Someone's asking me, what is the electrolyte? Electrolyte is what we are running the electricity in. So that's the battery. And electrolyte is where the electricity is passed. So that's molten or dissolved ionic compound. Here is my electrolyte. Okay? Any question? Now, we're going to get to one question that is super important. They do ask you about this very often, which is the extraction of aluminium. Again, this is one topic or one simple question that comes really, really very, very often. What does extraction mean to start with? Extraction meaning you get the metal in its metallic form, like aluminium. You get it as it is. From where we get all of our metals? Most metals, you get them from what we call an ore. What does the word ore mean? Ore, it's like a rock that has the metal ion in it. So it's a rock with the metal ion, the positive metal ion, inside this rock. For aluminium, our choice of metals, this is known as the rock itself, the ore, I should say, is called bauxite. Look what I wrote under its name. I wrote his name here, and I wrote its melting point. And why am I interested in its melting point? I am very interested in its melting point because I need to melt it. If I am to get the aluminium from inside this ore, I must melt it. And you can see here that the melting point is extremely high. For that reason, I need to find a way around, because there's no way I could make money with that much melting point. What does money have to do with this? Look, I want to get this aluminium and I want to sell the aluminium at some point. Your cost of production has to be low so that you can make money selling this aluminium. But to melt some rock at such a very high melting point is going to cost you a fortune. That's why they found that if they could just dissolve or mix this ore with some salt here, that is going to reduce its melting point. So again, as it is, the rock here has very high melting point. They have decided to sprinkle some salt. This salt has a name, but when you mix that salt with the ore, you drop the melting point in less than half. So instead of me spending heat, energy, fuel, trying to reach to 2000 degrees, now all what I need is to supply heat up to just 900. So that's a huge reduction in the melting point. Again, what we call this salt that I will mix with the ore, the ore's name is bauxite, okay? The salt that I'm gonna mix with is called cryolite. And the salt here got sodium in it, which helps me to, other than like reducing the melting point, it helps me a lot to also make this compound, to make this molten compound, make it have higher conductivity. I repeat, you are to do what? You are to extract aluminium. To extract aluminium, you will require the source. The source of aluminium is this rock called bauxite, which is made of aluminium ions. It's group 3 element, so Al3+, and oxide. My task here is to get rid of the oxide, and I'm interested in the aluminium. To do electrolysis of any ionic compound, I must melt it. And there's no way I will melt it at such a very high melting point. For that reason, we have decided to do what? We have decided to add some other compound. This other compound is called cryolite. This cryolite thing is sodium, aluminium, and fluoride. So it's a compound made of 1, 2, 3 ions. Why 3 ions? Because I'm not only interested in reducing the melting point, I'm also interested in making it a better electrical conductor. And the more the ions, the better the conductivity. So next time someone asks you, why is it when I am to extract aluminium, why do I have to add this cryolite? There are 3 reasons. First, you are reducing the melting point. Second, you are improving conductivity by adding all these ions. Number 3 is that you are reducing your energy cost. Instead of paying money, paying fuel to reach to 2000 degrees Celsius, you are now just paying for 900 degrees Celsius, which is way less energy. You may tell me, what does energy have to do with melting? It does. Don't you need to burn fuel to supply the heat? That's what the energy is about. Okay? So what did we learn so far? We learned the word ore, and we learned the ore of aluminium. What did we call it? We called it bauxite. We know probably its formula. The formula of bauxite is Al2O3. Reason, because it's made of Al3 plus and O2 minus. You write it like drop swap. You do get Al2O3. Okay? And we found it melts at such a very high melting point, so nearly 2000 degrees Celsius. We dropped that temperature to 900 degrees Celsius. How? We added some other ionic compound to it. We call this other ionic compound, we call it cryolite. Cryolite is aluminium, sodium, and fluoride. Okay? So it's 3 sodiums, 1 aluminium, and 6 fluorides. Where does this 6 come from? Because look, my friend, you have 3 positive sodiums. Aluminium is 3 as well, because this charge of aluminium all the time is 3. So to cancel those 6 positive charges, you need 6 negative charges. So the formula of cryolite, NaAlF6. What's the reason for the cryolite? We said there are 3 reasons. Number 1, it's to drop the melting point, save energy, and 3, to make this compound, to make the mixture of aluminum oxide and cryolite have better conductivity. Okay? This is the first thing. Tell me if you have a question. Now, let's get... You have a question? Tell me.
Mister, for example, what can it ask us for the aluminium one? Like, we need to do all of the steps?
What steps?
No, because Mister, I'm confused. I don't really understand how to do like the steps to do the electrolysis of aluminium.
But we did not study them yet. How do you understand them if you did not do them yet? We did not do them. We did not even start. How did you get confused?
Mister, what is the thing here? The Al bauxite, what's the thing under it?
This, the one in blue?
No, the one on the left.
This? You don't know what that thing is?
Yeah.
Like, you know where you didn't know where the aluminium came from?
No, Mister, I know, but I meant like, what is the thing called for all of those?
What the thing's called for all of those? Can you listen? So maybe you understand? Listen to what I'm saying here. So again, I am taking here this, the bauxite thing. I am taking this, which is the cryolite. I'm gonna mix them up with one another for all the good reasons we've seen before. So this and this are gonna be put into some furnace like here, and I will start to heat and mix. So they'll be combined, they'll be mixed, they'll be molten at 900 degrees this time. And while molten, I will have the ions of aluminum, which is I am interested in. That's the Al3 plus, that's what I'm interested in. And O2 minus, which is really not very interesting for me, but I need this. That's how I'm gonna make my money. Okay? So what's the setup is like? It's electrolysis. And for electrolysis, you need cathode, anode. Where will you place the cathode? Think about it. Cathode must be placed here at the bottom. So do you see this entire container here? This entire container here is graphite from the inside. Graphite is a good conductor of electricity, and I've linked it to the negative electrode. Okay? Why did I place the cathode at the bottom? Because it's where the aluminium is gonna drop. It's a metal. Metals are dense, metals are heavy, they will sink at the bottom. And check where I've put the anode. I put the anode at the top. Why anode was put at the top? That's because it's the oxygen gas. Don't we get oxygen now here with the oxygen ions? So the oxygen gas is gonna collect here at the top. We know it's a gas, it's gonna fly or it's gonna be collected there at the top. Okay? So again, the setup is made of graphite, anode, cathode, all made of the same conductor, graphite. Here at the bottom, you would start to see in just a little while, you start to see some molten aluminium. Okay? And here at the top, you will notice some gases forming here at the top. Let me show you in real time how it's going to look like. It's going to look like this. So again, this is from the outside. From the inside, I have graphite and graphite. This is the molten aluminium oxide and cryolite. Okay? These are the ions are now free to move because we've just melted it. Check the aluminium now at the first. Aluminium is collecting at the bottom. The Al3+ goes down. Close look. It's gaining 1, 2, 3 electrons. Turn into aluminium atom. Okay? Now it's turning to aluminium metal. How about the top? This is oxide. Did we say oxide is the other ion I have? It's losing electrons this time, and it's going to become oxygen gas. Okay? So once again, this setup is going to look like this. Here I have graphite. And there at the top, I also have graphite. Is the best choice in terms of conductivity and in terms of cost. Quite cheap. This is negative, and here it's always positive. I'm expecting aluminium to form here, gaining 3 electrons, turning to aluminium metal. And I'm expecting the oxide to form here and is gonna lose electrons. O2. Remember, I need to balance this all the time. So these are 2 oxygens, right? Just put 2 here. What am I also missing? I am missing 2 times 2, so 4E-. So these are the equations, and this is what would make us the money here. We'll sell the aluminium. What is aluminium used for? You can use it for foil paper in your kitchen, utensils, even the phone body is made of aluminium. Airplane bodies, so many. Look at your windows in your house. They're all aluminium. Very widely used. I just have few more details related. My first one is this thing. I want you to take a look here at the anode. Those graphite anodes I have at the top. Didn't we just say that oxygen is forming here? And graphite is carbon, right? So something weird happens at the moment. You'll notice some black smoke forming. Why is there smoke forming there at the anode? Why is that my anodes are getting used up? The anodes are disappearing. Simply because we are forming oxygen here. And we already have carbon. Okay? So again, this is carbon. And there is oxygen. Guess what's going to happen at the moment? That oxygen we formed and the carbon in the anode, they're burning it. So your anodes will soon burn, because it's just like barbecue. When you do barbecue, you blow air, oxygen on the charcoal. That's the exact same thing here with the anode. That's why it's very advisable to keep changing your anode, because they will simply burn. It's heat, oxygen, carbon, recipe to burn the anode. So every now and then, what am I supposed to do? I must replace those anodes. Okay? So one last recap. This is the container. From the outside, it's steel. Not very necessary, but it's helpful to understand that I need something to be strong and high melting point. From the inside, it's entirely covered with graphite. It's graphite here. I will hang some more graphite here at the top. Where are these? This is my anodes, all connected to the positive. And this is my cathode, connected to the negative. Okay? You will turn this aluminium into aluminium atoms, reduction, and your oxygen is forming here, but it reacts with the carbon in the anodes, forming carbon dioxide. Someone's asking me, is all aluminium gained from this? Yeah, most aluminium we have around is either recycled, you recycle old aluminium, or you get it this way. Okay, so let me do quick recap here. First one, look what it says. It says fluoride is oxidized. Where did this fluoride in the first place come from? Where did this come from in the first place? This is the cryolite. Didn't we say that the cryolite was Al, Na, and F? So this fluoride from your cryolite, it would end up where? Since it's negative, where's it going to end up? This is going to end up at your anode. So that's one product expected there at the end. But again, I'm not really interested in this. I'm not even interested in the oxygen. All what I'm interested in is the aluminium. Do you guys still remember how did we manage to reduce the MP? That's the melting point. So what was the thing that I did to reduce the melting point?
Mix the bauxite with cryolite.
So we mixed the bauxite with the cryolite. And it says oxygen reacting with the anodes. So when the oxygen reacts with the anode, what am I supposed to do to solve this issue? So what is the product going to form here? As this reacts with the anode, you're going to get what? You're going to get CO2, right? That's why we replace these anodes. Here it says graphite burns out in oxygen. So how am I supposed to solve this issue? Since the anodes are burning, then I must really do what? Then I must change those anodes, right? Here it says aluminium is heavy. Aluminium has high density. So in advance, we decided to put what? We decided to place the cathode. Where did we place the cathode? We placed it here. That should be negative, actually. Should be placed here at the negative. Okay? Finally, bauxite is melted. So why did we melt the bauxite? We melted this just to make sure it's first reducing the melting point and to improve the electrical conductivity. Okay? You have any question about these?
Mr. I just have a question, sir. I raised my hand to answer that.
Okay.
Okay.
You don't memorize them. They will ask you about either the left side or the right side. So for every one of these are problems and these are the solutions. So they ask you something, how did you lower the melting point? You tell them we mixed it with cryolite. They ask you like when the anodes are changed, why they're changed, because they are burning. How does carbon dioxide form at the anode? That's because the anode is carbon, that's graphite, and it reacts with oxygen. Graphite reacts with oxygen. Where did the oxygen come from? It came from the electrolyte, coming carbon dioxide. Let's write this as summary. Aluminium is, so it's extracted from aluminium oxide by electrolysis. So what kind of element, what kind of metal is aluminium so that we can extract it by electrolysis? In other words, do you see these elements here, like gold, silver, platinum? These are very unreactive metals. These metals, you never do any electrolysis to extract them. Reason? Because they exist as they are. Gold is found as gold. When you find gold, lucky, it's going to be gold. You're not going to find gold oxide. So again, the reason why we put all the effort, money to extract aluminium, because it's not one of those unreactive metals. So the reason here, it's because it is a reactive metal. Next, look what it says. Before adding to the cell, aluminium oxide is mixed with to lower the melting point. So what am I going to call this compound?
Cryolite.
Cryolite. A layer of around the inside of the cell. So what did we pack or what did we wrap the cell with so that it would become the positive and negative electrodes? In other words, what did we make the positive and negative electrodes from? Both of which were made of the same thing, which is?
5 minutes.
Okay, you said graphite? I hope so.
Yes, sorry, we're in the car right now.
Okay. In the cell, the mixture of aluminum oxide and cryolite is, and A is passed through it. So in this cell, the mixture of aluminum oxide and cryolite is, and is passed through it.
It is melted and a current is passed through it.
All right. Finally, it says molten aluminum is formed at the. Where are you supposed to get the aluminum? Did we form it at the cathode or the anode? Where we're trying to make it. It was formed there at cathode, right? Negative cathode. Okay. All right, I think, yeah, we're fully done for today. Let me know if you have a question. Otherwise, I'll see you next time. See you on Wednesday.
Bye.
Bye.
Mister, can you please explain just one example of the cathode anode oxidation and reduction? Go back to the thing and just explain one more example.
Yeah.
Thank you, sir.
Adil, you have a question?
Sir, can you go to the first page? I forgot to write it down. Like the ionic compounds one.
Oh
Just
yeah,
wanna write it down.
yeah. This?
Yeah, thank you.
Well-
Just a sec.
So one example of what happens at cathode is gonna be some metal, positive, gains an electron and becomes metal. That's a cathode reaction. And one example of what happens at the anode is gonna be non-metal. Lose an electron, becomes a molecule. This is going to be oxidation. Great cut. And this here is oxidation.
So at the anode it's oxidation,
Yeah.
and at the cathode is reduction. Okay.
And
Thank you.
for extraction, we took this graph